to all of you. Today we are going to discuss about various problems. The forces 25 Newton, 35 Newton, 45 Newton, 55 Newton and 65 Newton are acting at one of the angular points of a regular hexagon towards the other 5 angular points taken in order. Find the magnitude and direction of the resultant force. It's a very simple problem. First we have to draw the hexagon, because all the forces 1, 2, 3, 4, 5 forces are acting at one of the angular points of the regular hexagon. So, first we have to draw the hexagon, right. So, this is the hexagon, right. So, first force is 25 Newton. So, 25 Newton is acting in the horizontal position. This is called as 25 Newton, and the next angular position. So, from this point, so this is one corner. So, draw a line which is passing through this corner. So, this is called as 35 Newton. Similarly, one more corner from this point, draw a line. So, this is 45 Newton, and from through this corner draw a line, right. So, this is 55 Newton and the last one is this. So, this is 65 Newton, right. So, this is the problem. Now we have to find the angles, right. So, the included angle of the hexagon, included angle of hexagon, first we have to calculate, which is equal to 180 degree minus 360 degree divided by, and this is the general formula. So, 180 degree minus, so 360 degree divided by how many sides are there? So, 6 sides, right. So, which is equal to 120 degree for the included angle of the hexagon. Now, we have to find the theta, right. So, theta which is equal to 120 divided by, so this is 1, 2, 3, 4 angles are there, divided by 4, which is equal to how much? 30 degree. So, theta which is equal to 30 degree, right. Now, each forces, the force which is acting with the angle, then this force is divided into two components. One is horizontal component, another one is vertical component. Whatever may be the force is acting with some inclination, then that force is divided into two components. One is horizontal component, another one is vertical component, right. So, each force except this 25, because 25 is acting horizontal, right. Clear? So, now the force 1 which is equal to 25 Newton and acting 0 degree, right. Then what is the horizontal component and what is the vertical component? The horizontal component which is equal to 25 cos theta, right. So, see this force that this is 25. So, horizontal component and vertical component which is equal to 25 sin theta. Similarly, F2 which is equal to how much? 35 Newton and acting 30 degree. So, this theta which is equal to 30 degree, right. So, this force 35 Newton is acting with 30 degree inclination. So, this force is divided into vertical component and horizontal component. This is 35 and this is 35 and this is 35 sin 30 degree and this is 35 cos 30 degree. So, this is horizontal and this is vertical, right. So, now vertical horizontal component which is equal to 35 cos 30 degree and this is 35 sin 30 degree, right. Similarly, we have to calculate F3 which is equal to 45 Newton and acting which is 60 degree, right. So, 45 cos 60 degree and 45 sin 60 degree. Similarly, F4 which is equal to 55 Newton and acting 90 degree, clear. So, horizontal component 55 cos 90 degree and 55 sin 90 degree, right. So, the last one which is F5, right. What is the angle? Magnitude which is equal to 65 Newton and angle which is equal to 120 degree. So, 65 cos 120 degree and 65 sine 120 degree, right. So, calculate this sum of these forces. So, this is sum of horizontal forces, right, f of x, and this is summation of f of y, vertical forces. So, calculate this, which is equal to 45.31. Similarly, sum of these vertical forces, then we will get 167.76, right. Now we have to calculate the resultant forces, right. So, resultant, what is the formula? Resultant, or which is equal to root of sum of horizontal forces squared plus summation of horizontal forces squared plus summation of vertical forces squared, right. Now, the resultant, which is equal to root of sum of f of x squared, I mean summation of f of x squared, I mean summation of horizontal forces. So, 45.31 square plus vertical summation of vertical forces, how much? 167.76 squared, right. So, now calculate this, which is equal to 30196.4137. So, take root, or which is equal to 173.77 Newton. So, this is actually the resultant of this problem. Now, we have to calculate the angle which is acting in this resultant. Now, tan theta, which is equal to, we know that formula, sum of vertical force divided by, I mean summation of vertical force divided by summation of horizontal forces. So, summation of vertical force, which is equal to 167.76, we know that, divided by summation of horizontal forces 45.31, right. So, tan theta, which is equal to, what is the value? Tan theta, which is equal to 167.76 divided by 45.31, which is equal to 3.702. So, theta, which is equal to tan inverse of 3.702, right. So, tan inverse of 3.702, which is equal to 74. So, theta, which is equal to 74.88 degree, right. So, resultant, which is equal to 173.77 Newton, and summation of f of x, which is equal to 45.31, summation of horizontal forces, which is equal to 167.76, and theta, which is equal to 74.88 degree, right. Then the next problem, a semicircular area is removed from a trapezium as shown in the figure below. Determine the centroid of the remaining areas. All the dimensions are in mm. So, this is 40 mm and 40 mm, this is 30 and this is 60, right. So, this is the given picture. We have to divide this picture into 3 sections. One is rectangle and triangle and semicircle, right. Clear? Now, we have to solve this problem. It is a very, very simple problem. We have to find the centroid of the given section, right. So, this given section is not similar, not symmetric for x axis and not symmetric for y axis. Then we have to find x bar and y bar, because the given section is not symmetric about x axis and not symmetric about y axis. So, for that purpose we have to find x bar and y bar, right. So, we divided already section 1, which is the rectangle, right. Now, we know that what is the area of rectangle? Length B, which is equal to length, which is equal to 80 into 30, which is equal to how much? 2400 mm squared. And now we have to calculate x1, which is equal to how much? 40 plus 40, 80 divided by 2, which is equal to 80 divided by 2, which is equal to 40 mm. and y1 which is equal to 30 divided by 2, 30 divided by 2 which is equal to 15 mm. Right. Now, take section 2, right. So, section 2 which is a triangle, right. What is the formula for triangle? Of BH, right. Substitute of into B which is equal to 30 into H which is equal to how much? 80, right. Here 30 which means 60 is there. So, 60 minus 30 which is equal to here 30, and this length which is equal to 40 plus 40, 80, right. So, what is the value which is equal to 40, which is equal to 1200 mm squared. Now, we have to calculate x2, x2 which is equal to how much? X2 which is equal to 80 into 2 divided by 3, right. 80 into 2 divided by 3, right, 2h by 3, right. That is the formula, 2 into h divided by 3, right. So, what is the value? 53.3 mm, and now calculate y2, y2 which is equal to, what is the value? Here 30 is there, right. This is the reference axis. So, from this point to this point which is equal to 30. So, first we have to calculate 30 plus h by 3, 30 divided by 3, h which is equal to this, right. So, which is equal to how much? 40 mm. So, similarly take section 3, right, section 3 which is equal to semicircle, clear, semicircle. So, what is the area of semicircle? A3 which is equal to pi r square divided by 2, right, pi into r which is equal to how much for this? Dia which is equal to 40, r which is equal to 20 mm, right. So, 20 square divided by 2. What is the value of area? 6 to 8.3 mm squared. Now, calculate x3, x3 which is equal to, what is the formula? This 40 from this axis plus r I mean 40 divided by 2, right. So, 40 plus 40 divided by 2, 40 plus 40 divided by 2 which is equal to 40 plus 20 which is equal to how much? 60 mm. Similarly, y3, y3 which is equal to, what is the formula for this? y3 4r by 3 pi, general formula is there, 4r by 3 pi. So, 4 into 20 divided by 3 into pi. So, what is the value? Which is equal to 8.5 mm, right. Now, we know that area of the rectangle and x1 y1. Now, section 2 triangle, area of triangle 1200 mm squared and x2 which is equal to 53.3 and y2 which is equal to 40. Now, A3, right, area which is equal to 628.3 mm squared and x3 which is equal to 60 mm and y3 which is equal to 8.5 mm. Now, we have to calculate x bar. What is the value of, what is the formula for x bar? X bar which is equal to A1 x1 plus A2 x2 and now minus A3 x3. We have to subtract this A3 from this total section, divide by A1 plus A2 minus A3. We have to subtract section 3 from the total section, right. So, this is the formula for x bar, and what is the value of, what is the formula for y bar? Y bar which is equal to A1 y1 plus A2 y2 minus A3 y3 divided by A1 plus A2 minus A3, right. So, substitute all the values in this equation, right. Then this is x bar which is equal to, what is the value? Substitute all the values because we have all the values, and now x bar which is equal to 41.1 mm and y bar, what is the value which is equal to 26.5 mm. So, this is the value of x bar and y bar. Okay.